Good afternoon. Welcome to Mission Control Houston and the International Space Station Flight Control Room. This is where a team of specialists is always on duty to assist the astronauts and cosmonauts with their science and maintenance tasks on the station and to monitor the operation of the station's systems as it orbits 250 miles above our head. This week, Expedition 55 officially began as Commander Anton Shkaplerov and flight engineers Scott Tingle and Norishige Kanai waved goodbye to 3 crewmates who closed the hatch and headed for home after more than 5 months in space.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Catherine McLaurin. It's always hard to say goodbye, but the Expedition 54 crew did just that as they returned to Earth earlier this week. NASA astronauts Mark Vande Hei and Joe Acaba, as well as Russian cosmonaut Alexander Mersurkin, said their farewells before undocking the Soyuz MS-06 spacecraft for the return journey to Earth. The crew safely landed Tuesday evening at 9:31 Eastern Time in a remote part of Kazakhstan. This crew marked the beginning of the first long-term increase in crew size on the U.S. segment. This enabled NASA to double the time dedicated to research and achieve a record-setting week of over 100 hours of research in space. In addition to research, the crew welcomed 4 cargo spacecraft, participated in multiple spacewalks, and dozens of educational events as a part of NASA's Year of Education on Station. With one crew home safe, another crew is prepping to launch. NASA astronauts Ricky Arnold and Drew Feustel and Oleg Artemev of Roscosmos are in the final weeks of training before they launch to the station in late March. This will be the second flight to station for the trio and the first long-duration stay for Arnold and Feustel. Artemev was the flight engineer during Expedition 39 and 40 in 2014. They will join Anton Shkaplerov, Scott Tingle, and Norishige Kanai aboard the station to complete the Expedition 55 crew. This week's Twitter question comes from Misha, who wants to know, what do the astronauts do with the garbage on ISS? As you can imagine, there are no garbage trucks swinging by the station once a week to collect the trash. Astronauts pack and organize any waste on cargo vehicles like orbital ATK Cygnus, a Russian Progress vehicle, or a Japanese HTV spacecraft. Once these vehicles are released, the thousands of pounds of trash, including food containers and dirty laundry, burn up in the atmosphere over the Pacific Ocean. And even though they are back on Earth, Joe Acaba and Mark Vande Hei are continuing their year of education on station with a tweet chat on March 6th. They will be talking with their social media followers on their individual accounts with the hashtag AskAstro. Joe will answer questions from @AstroAcaba from 1:15 to 1:45 p.m. Central Time, and Mark will answer questions from @Astro_Sabo at 2:55 to 3:30 p.m. Central Time. Keep sending in questions using the hashtag #SpaceToGround. We'll see you next week.
Well, the year of education on station is not over just because former teacher Joe Acaba has come home. NASA astronaut Ricky Arnold is also a former teacher, and he'll be on board in just about 3 weeks to bolster the activities designed to help teachers and students get the most out of learning about science, technology, engineering, and math. In the meantime, here's another of our STEMonstration videos, this one featuring Randy Bresnik on the topic of Newton's second law of motion.
Hello everyone, I'm astronaut Randy Bresnik, living and working aboard the International Space Station. Now, on the space station, we live in a microgravity environment. Do you think the laws of physics will hold up? Come on, let's go find out.
The acceleration of an object depends on the net force acting on the object and the mass of the object, or F equals ma.
Surely good show, Sir Isaac.
Here we see that once the force of the thrust is greater than the weight of the vehicle, the rocket begins to accelerate.
All right, we're gonna start with something small. Something you might have at home. A little stick of chapstick. We'll go ahead and use our force, being our bungee cord here. We'll put it on our bungee, and we'll pull it back. And let it go. And you can see how fast it accelerates because there's very little mass. Next, we'll try a little spaceship. A little more massive, and you can feel that because as you move it, you can feel that the kind of the force, the extra force you have to push with your hand. So we'll put our spaceship on our launcher here, same spot. Notice it's flying a lot slower than that chapstick did. What we've seen is the same amount of force on a smaller, less massive object means the acceleration is faster. Well, this is the biggest and most massive thing we have. So let's see how the acceleration is affected. Pull back the same amount on the force, and here we go. And there you have it, Newton's second law of motion in action. Thanks everybody for exploring a little physics with me today. Now I'm going to send it back to Earth so you can start your experiments. See you again real soon.
Being in the microgravity environment of Earth orbit for a long period of time causes changes to an astronaut's musculoskeletal system, including muscle and bone weakness and bone density loss. With that in mind, there's a medical breakthrough aimed at rebuilding bone and possibly blocking bone loss, which is now being investigated on the International Space Station. Chia Su, a researcher at UCLA, explains recent success testing a new drug on Earth to grow bone and discusses what she and her colleagues hope to learn through research in microgravity. The therapies developed here have the potential of benefiting millions of patients worldwide suffering with osteoporosis or extended bed rest and other symptoms.
One of the projects we're working on is how to better grow bone, both on Earth and in space. Part of our project for bone regeneration is asking the question, how does Mother Nature grow bone? Osteoporosis, as you may know, is a huge, huge problem. So if you imagine on Earth, after the age of 50, you lose about half a percent of your bone mass per year. But in space, the astronauts under microgravity conditions can lose about 1.5% per month. So that has enormous implications for longer-term space flight. Now that we have this molecule, we know it forms bone, the thing is, how can we make it work in space? Microgravity really offers a unique situation. What we hope to learn is that this molecule can help reduce bone loss and maybe restore lost bone. We've been doing a lot of testing on Earth now to perfect everything. We've identified the function, modified it to make it last longer, and so we've shown that it very significantly promotes bone growth in osteoporotic models. So it really offers a unique experimental system you can't recreate on Earth.
Keeping the human crew members healthy on their long missions to the International Space Station is an important part of space station science. The longer that we have people in space, the more we learn about how different aspects of that environment impact human health, and the more we teach ourselves about how to counteract the negative effects so future space explorers can stay healthy enough to finish their missions. For example, there are studies underway now looking at how different spectra of light impact the astronauts' sleep.
The Power of Light, presented by Science at NASA. Crew members on the International Space Station, or ISS, can experience sunrises and sunsets in rapid succession, about 16 sunsets per day because the space station circles Earth once every 90 minutes. Most people function regularly on a 24-hour cycle known as a circadian rhythm. However, the space station environment creates a departure from the cycle of light and dark astronauts are used to at home. A high workload, the need to work night shifts, the excitement of spaceflight, plus the unusual environment can disrupt astronaut circadian clocks. These factors can combine to disrupt sleep, which can in turn affect performance. Being wide awake when they should be sleeping is in fact a long-standing challenge among ISS crew members. Studies of astronauts who flew between 2001 and 2011 on the Space Shuttle and 2006 through 2011 on the space station showed that astronauts slept considerably less in space than they did on Earth. About 3/4 of them reported using sleep-promoting pills during their 6-month missions. Use of caffeine is also commonplace among ISS astronauts, to fight off the daytime drowsies. But NASA is seeking a better way to solve the problem. The secret lies in light itself. It's known that the blue-enriched light emitted by our laptops can keep us awake at night. A new NASA study will investigate how to use that for the benefit of humankind and not just on the ISS. This light study, known as the Lighting Effects Study, coincides with the lighting makeover on the space station. The fluorescent lights on the station are being replaced with a new system of solid-state light-emitting diodes, or LEDs. Not only are the LEDs more energy efficient and safer, they can literally shed all sorts of light on the study topic. Brigham and Women's Hospital's Dr. Stephen Lockley and Thomas Jefferson University's Dr. George Brainerd are the co-principal investigators of the lighting effects study. Lockley explains, light has a number of effects on our sleep and circadian rhythms, is a natural stimulant, and can improve alertness and performance and also help reset the 24-hour clock when it gets out of sync. The human eye contains a light-sensitive protein called melanopsin, different from the rods and cones that we use to see, which detects light in the eye and mediates these effects. Melanopsin is most sensitive to short wavelength blue light, and so by increasing or decreasing the proportion of these blue wavelengths in white light, we can enhance alertness or promote sleep respectively. Lockley says NASA has developed a multi-LED lighting system to take advantage of these light effects. The system can provide millions of different light spectra. We're not making the ISS into a disco, but we are going to use 3 different light settings. We'll use a general light setting that provides a good light to see by during normal work, a higher intensity blue light enriched setting that elevates alertness and can better shift the circadian clock when needed, and a lower intensity blue wavelength depleted pre-sleep setting to calm the brain and promote sleep. We will be studying the impact of these lights in future missions.
Oh, you guys, it is so fancy. It is really awesome. I think the technical term is light functional checkout was successful, so congratulations to the light team.
Results of the study are expected to help define guidelines for lighting protocols during future ISS and human space missions. Study results should make it clear exactly when and how to use these various settings of light intensity and spectrum. These results could also lead to Earth-based benefits, such as helping manage sleep patterns for shift workers, or even developing treatments for sleep disorders or jet lag. For more from the International Space Station, visit www.nasa.gov/station. For more news about the power of light, stay tuned to science.nasa.gov.
Not all the science on the International Space Station is about human beings. Some of it is designed to learn about the space environment for its own sake. For example, we know neutron stars are small and extremely dense, but there are still many aspects of these remnants of explosive deaths of other stars that we don't yet understand. NICER is a facility on the outside of the International Space Station that seeks answers to decades-old questions about extreme forms of matter and energy. And data from NICER will also be used in Sextant, an onboard demonstration of pulsar-based navigation. The mission of the Bigelow Expandable Activity Module on the International Space Station has been, well, expanded. After more than a year and a half on orbit, providing performance data on expandable habitat technologies, NASA and Bigelow Aerospace reached agreement to extend the life of the privately owned module. For a minimum of 3 more years, Beam will be a more operational element of the station, used in crew activities and onboard storage, and that'll allow time to gather more data on the module's structural integrity, thermal stability, and resistance to space debris, radiation, and microbial growth. The International Space Station is a crucial stepping stone to future deep space exploration. It also serves as a unique scientific platform, enabling researchers from all over the world to conduct innovative experiments that can't be done anywhere else. Now, each of the station's partner space agencies has their own distinct goals for space research, but they all share one goal: to extend the resulting knowledge for the betterment of humankind.
It's a big, beautiful blue planet, and the adventurous natives have been exploring it all over from the very beginning. Lately, they've been exploring off the planet, determined to discover what's out there. But as luck would have it, their pursuit of their future has also been building their present. They're enjoying benefits today that are coming out of the work about tomorrow, work that's being done right now aboard the International Space Station. Since Expedition 1 arrived on orbit in the year 2000, there have been more than 1,500 investigations active on the International Space Station in fields like medicine,
protein crystal growth, combustion, metallurgy, basic science, space science, Earth observation for disaster recovery and relief.
And many of those experiments and research projects have produced beyond the original intent. For example, a lot of the work in medicine was designed to keep astronauts safe in space, such as research on how to keep crew members from losing bone mass and weightlessness. And the researchers found that nutrition was playing a part.
Individuals had more iron storage in their body, had more oxidative damage, and had more bone loss in certain regions.
So, more attention was paid to providing foods with the right kinds of minerals and nutrients. Then, there was better exercise support, like an upgraded exercise device that proved its effectiveness in crew members who flew with it after having flown without it.
For the first flight, I lost 99% of bone loss. After the second flight, during all those prescriptions and exercises that I've been told to do, from bone loss perspective, I lost nothing.
The right combination of exercise and diet and vitamin D supplements meant no bone loss.
So there's been a huge development of our understanding of bone processes, why astronauts are losing bone, and how the bone remodels and recycles itself. Understanding that process helps us protect astronauts, but it also has the benefit of giving new insights into understanding those same processes on Earth, where so many people are worried about bone loss.
Another example of station research providing a benefit on the ground: water reclamation. Early on, the station crew members relied on space shuttles and other cargo ships to deliver fresh water. But the long-range plan was for a more self-sufficient station with a system that turns wastewater into pure drinking water.
On board the space station, we've had a water recovery system in use since 2008. This system recovers 90% of the water that we fly to the space station. This technology will be vital for our long-duration missions, and that's because on a deep space mission, the water resupply won't be practical.
And where else do you think this technology is proving useful?
The water treatment system that we developed for the space station has been deployed over the last 10 years now all over the world.
When you get involved with a plant of this kind, if it is well used, it can change the lives of an entire community. It gives you children that learn more. It gives you parents who spend less money on medicine. It changes the future.
And then there's space station activity that was designed to benefit people on Earth. For example, students on Earth, from grade schoolers through postdocs. Since the beginning, station crew members have used an amateur radio to talk directly with students on the ground, answering questions and inspiring some of them to careers in science, technology, engineering, and math fields. More than 500,000 students have learned about geography and teamwork and communications and problem solving by participating in an experiment that lets them control a camera on the station and aim it at targets on the Earth of their own choosing. The Spheres experiments originated to test algorithms related to formation flying, but it's evolved to include students in the design and execution of those robotic flights. The International Space Station has a lot of goals. Not only is it getting people of this planet to work together and enabling deep space missions of the future and seeding the growth of commercial space ventures, it has an ambitious agenda of laboratory science and technology research that's using the unique environment of low Earth orbit to learn what can't be learned here on the ground, to help people on the planet right now.
There is a lot of science done on the International Space Station that has benefits for those of us who are stuck on this planet. But we also get something out of at least one of the leisure activities of the station crew members. We get to look at the pictures of Earth taken by the astronauts and cosmonauts nearly every day. Over a year, that adds up to thousands of photos. The people at the Earth Science and Remote Sensing Unit at NASA's Johnson Space Center in Houston poured through last year's crop to pick out their top 17 photos of Earth for 2017. would like to get another look at any of the stories we featured today, check us out on YouTube and Facebook. There are the addresses right there in that handy blue box on your NASA TV screen. While you're there, look at all the other great stuff that you can find about NASA and America's human spaceflight program. If you're interested in good conversation about space exploration, check out Houston, We Have a Podcast. This features folks here at NASA talking about their work and their personal experiences on the job. We post the new episodes on Friday, and today, March 2nd, my colleague Dan Hewitt fills in for Gary Jordan in a talk with astronaut Drew Feustel about his upcoming mission to the International Space Station, also about his first flight to upgrade the Hubble Space Telescope, and the unusual route that he took to becoming an astronaut. Go to www.nasa.gov/Johnson/HWHAP, as in, all together now, Houston, we have a podcast. You'll find all of the episodes there. You can listen there on nasa.gov, also on SoundCloud and on iTunes. This is Mission Control, Houston.